This video is part of the MCAT Chemistry video course. Subscribe if you'd like notifications about the release of future MCAT videos, and please visit ancientbrainstutoring.com for questions about one-on-one virtual MCAT tutoring. In this video, we're going to cover atomic basics, so things like the structure of an atom, element symbols, isotopes, atomic mass, atomic number, and atomic weight. Starting off with the basic structure of an atom, if you look at the image on the bottom left, here is an image of an atom. And the center of it has the nucleus, which contains the protons and the neutrons. And protons are positively charged, while neutrons do not have any charge. Electrons orbit around the nucleus, and electrons will have a negative charge. And on the right side, we have an element symbol, so this is what will be used to represent elements. X is just a placeholder, so X could be whatever letters are used to represent the element that you're working with. And around the element symbol, we have three important things. First is Z, which is the atomic number, and the atomic number will be equal to the number of protons that are in that element. And then up top, we have A, which is the atomic mass, and the atomic mass includes the number of protons and the number of neutrons. And the reason those two are included are because those two have substantial masses, where electrons have virtually no mass. And the mass of protons and neutrons is still super small, but electrons are way, way smaller than even those. And then on the top right, we have the charge. And you find the charge by taking the number of protons and subtracting the number of electrons. Now, it's really, really important that you don't ever change the number of protons for a particular element whenever it has a charge. Because the number of protons are really important because that is what determines the identity of an element. So if you ever change the number of protons, then you've changed what element that is. So if you had something like sodium, sodium has 11 protons. And then if sodium has a +1 charge, which it's usually found with, that does not mean that it gains a proton. Otherwise, it's no longer sodium. What that means is that it has one less electron. So it will always be the electrons that change. Now let's go over isotopes. Recall that the number of protons cannot change for a particular element. But what can change are the number of neutrons. And whenever you have two atoms of the same element and they have different number of neutrons, they are called isotopes. So we have carbon here, for example, and we have carbon-12 and carbon-13. And carbon-12 and carbon-13 are both going to have 6 protons. But then if we look at the mass, they have different masses, and the difference is going to be because of neutrons. So carbon-12 has 6 neutrons, where carbon-13 has 7 neutrons. The next thing we're going to go over is atomic weight. And you want to make sure that you're really clear on the difference between atomic mass and atomic weight. Recall that atomic mass is just the protons and neutrons of a single atom's nucleus. The atomic weight is if you took the atomic mass of all the isotopes of a particular element and then took the mean average of those atomic masses. And when you do this, if you take carbon, for example, carbon has two isotopes, carbon-12 and carbon-13. You can't just add 12 and 13 together and then take the average of those two. You have to take into consideration the percent abundances of those isotopes. So, for example, carbon-12 has a 98.9% abundance, which means that 98.9% of all carbon atoms are C12. And then only 1.1% of carbon is C13. And so you have to take the weighted average of those two isotopes. And we have to use those percent abundances in our equation. So our equation here is the atomic mass of isotope 1 times X, and X is the percent abundance of carbon-12. So that's going to be 98.9, but we're going to use the decimal form, so that's going to be 0.989. So we're just going to start filling out our equation. So first we have 12 times 0.989. And we're going to add, the next thing is the atomic mass of carbon-13, so that's 13 times 0.011, because 1.1% in decimal form is 0.011. And then we're just going to add those two together, and that gives you 12.011 for your atomic weight. And there's one more type of problem with atomic weight that we're going to look at. It's a little bit harder. It's pretty unlikely that you're going to see this on the test, but if you can do it and understand it, then you're totally good on atomic weight for the MCAT. In this next type of problem, we're solving for the percent abundances, and we're given the atomic weight. So we're going to use carbon again, so pretend like you don't know what the percent abundances are. We have our first equation that we used in the last problem written down, and notice that X and Y are now our two unknowns, because we know the atomic mass for carbon-12, we don't know the percent abundance, we know the atomic mass for carbon-13, but we don't know the percent abundance, and we know the atomic weight for carbon because it's given to us in this type of problem. What that leaves us with is two variables, which we can't solve with just this equation. So we're going to have to make another equation in order to create a system of equations to solve this. The second equation that we're going to use is x plus y equals 1. And the reason this is a valid equation is because we only have two isotopes. So x is the percent abundance of one, y is the percent abundance of the other, and they're going to have to add up to 100. So if you take the decimal form of those 2% abundances, they're going to add up to 1. And then we're going to use that equation to just solve for one of those variables. So I'm going to solve for x. X equals 1 minus y. And then we're just going to plug 1 minus y into the equation above and then solve for y. So when we do that, we end up with 12 times 1 minus y plus 13y equals 12.011. And then it becomes really easy from here. We distribute the 12, so we have 12 minus 12y plus 13y equals 12.011. And then that'll end up being y equals 0.011, which if we turn that back into percent form is 1.1%. And if you take your answer for y and plug it into the equation where x plus y equals 1, then that's going to leave you with x equaling 98.9%. And both of those percent abundances match the percent abundances of carbon-12 and carbon-13. And again, this is going to be about the hardest problem that you're ever going to run into with atomic weight. And in the next video, we will be going over radioactive decay.